Today we will discuss about distance and centers in a tree. Let Vi and Vj be the two vertices. The distance from Vi to Vj is the length of the shortest path from Vi to Vj and it is denoted by d of Vi Vj. Consider the below graph. To find the distances between two vertices V1 and V2, we need to find the paths between V1 and V2. The paths are A, E, the other path is A, C, F. Then we have B, C, E. Then we have B, F. The other path is B, G, H. And the other path is B, G, I and K. But distance gives us the shortest path. The shortest path from V1 to V2 are A with E and B with F with a length of 2 each. Therefore, distance between V1 and V2 is 2. Now, let us find the distance for this tree. The distance between A to B is 1. The distance between A to C is 2. The distance between C to B is 1. The distance between A to D is 2. And the distance between D to C is 2. Distance is a metric that must satisfy the following properties. The first property is non-negativity, then symmetry and then triangle inequality. Non-negativity means the distance between x and y should be greater than or equal to 0. That means it should not be negative. Symmetric means the distance between x and y can be equal to the distance between y and x. In triangle inequality, the distance between x and z and the distance between z and y should be greater than or equal to the distance between x and y. In this theorem, we are asked to prove that the distance between vertices of a connected graph is a metric, which is we have to prove that the distance between the connected graph is a type of measurement. The measurement which we are going to deal here is eccentricity. The other name for eccentricity is associated number or separation of a vertex. The definition for eccentricity is given by E of V, where E of V is the distance from the vertex V to the vertex furthest from V in a given graph G. We need to find the maximum distance from the particular vertex V to the faraway vertex in the graph G. Now, let us see the definition for the center of graph G. A vertex which has its minimum eccentricity is called center of the graph G. Let us find the eccentricity for this graph for all the vertices A, B, C and D. To compute the eccentricity of A, that is E of A, start from A and reach the faraway vertex. The faraway vertex for A are D and the other faraway vertex from A is C. Therefore, the distance of the furthest node for A is 2. Similarly, we can see that the eccentricity of B is 1, C is 2, D is 2. The center of this graph is 1, which is the vertex B, since B has its minimum eccentricity value 1. Now pause this video and it is time to think and write what is the difference between distance and eccentricity in a sheet of paper. Once you have done, continue with the video. Now let us find the eccentricity of this tree. To find the eccentricity of this node, the distance from this node to this node is 2. Because you will have a distance from this node to this node and from this node to this node. The distance from this node to this node is 3. Also, the distance from this node to this node is 3 because the path length will be 3. Hence, maximum distance for this node is 3. So, eccentricity value is 3. Similarly, we can compute eccentricity for other vertices also. Now, this tree ends up with 2 vertices of minimum eccentricity as 2. Hence, these two vertices forms the centers of tree. Such kind of tree is called two-center or bicenter. The next theorem is prove that every tree has either 1 or 2 centers. Consider this tree. Now let us see how we had computed the values 3, 4, 5, 6 and so on in this tree. To compute the value for each vertex, find its eccentricity. Now let us see how to find the eccentricity of this vertex. The distance from this vertex to this vertex is 3. The distance from this vertex to this vertex is 4. The distance from this vertex to this vertex is 6. Also, the distance from this vertex to this vertex is 6. Now, the maximum distance is 6, which is the eccentricity value for this particular vertex. Similarly, we can compute the eccentricity value for other vertices also. After finding all the eccentricity value of vertices, find the vertex which has the minimum eccentricity value. In this tree, the minimum eccentricity value is 3. Hence, the vertex that has the eccentricity of 3 is the center of the tree. Now, remove all the pendant vertices in the tree. What do you mean by pendant vertices? The vertex with degree 1 is called pendant vertex. By removing the pendant vertices, this gets removed, these vertices gets removed, these set of vertices gets removed, also this vertex gets removed. Finally, in the next step, we end up with this vertex. This, and this vertex. Now, we have reached this step T dash. Again, start computing the eccentricity value for each node of T dash. T dash has the minimum eccentricity value as 2. So, 2 is the center. Now, remove pendant vertices from T dash. So, this gets removed, and this gets removed. Removing the pendant vertices from T dash ends up in T double dash. Again, compute eccentricity at each vertex. T double dash has minimum eccentricity value of 1. Hence, the vertex 1 is considered to be the center of the tree. Again, remove the pendant vertices from T double dash, which ends in a single vertex, and that vertex will be the center of the tree. Whatever I had explained in the previous slide is given in written manner. Please go through this slide.